This is activity number 3 for lesson B-13. For this activity, you will need the assembled Raspberry Pi setup from previous activities, the assembled circuit from the last activity, a short male-to-male jumper wire, 2 long male-to-male jumper wires, and the IR line sensor. In this activity, you will add the infrared line sensor to the circuit from the last activity. You will also modify the program from activity number 1 to add the ability to sense input from the line sensor. Let's get started adding the line sensor to your circuit with your Pi powered off. Make the ground connection by adding a short jumper wire from N161 to A62. Make the 5-volt connection by adding a long jumper wire from C61 to P255. Make the output connection by adding a long jumper wire from B60 to B34. You're now ready to install the line sensor. In the last step, you make connections to rows 60, 61, and 62, and those will now be used for the sensor. Check the markings directly above the pins on the sensor and insert the sensor into the breadboard in column E so that out is in E60, VCC is in E61, and ground is in E62. This will mean that the LEDs on the line sensor are facing away from you when viewed with column A closest to you. This is the correct orientation to match the wiring you see here. The output of the IR line sensor is connected to channel 2 of the level shifter, but the output of channel 2 isn't connected to anything yet. Go ahead and connect the output of channel 2 to GPIO 20 by using a long jumper wire to connect I35 to I19. Power up your Raspberry Pi and open the program from activity number 1. You will make modifications to this program to add the input from GPIO 20, as well as program some additional LED behavior based on this input. Set up GPIO 20 as an input just below the setup line for GPIO 21. Here's the code to do that. You will use the blue LED color to indicate when the line sensor does not see an infrared reflection. Sensing a reflective object will cause the output from the line sensor to stay high. If this reflection is not present, like the lack of reflection caused by a black line, then the sensor output will be low. The low will flow through the level shifter and into GPIO 20. Add an elif statement below the if statement that will check to see if GPIO 20 is low or false. If so, that block will turn off the green and red elements and turn on the blue element. Turning off the blue element should also be added to the if block as you see here. Everything is looking good so far, except that the else statement is not yet addressing the blue LED. If the blue LED gets turned on by the line sensor, there is no code to turn it back off. Add a line of code to the else statement that will turn off the blue LED. Here is the entire program with the line sensor additions. Go ahead and run the program. Placing white paper near the line sensor will cause the RGB LED to turn green. Use a black marker to make a line at least 1/2 inch wide on the paper. Moving the paper across in front of the sensor will allow the sensor to indicate where the edges of the black line are located by turning the RGB LED blue. Verify that your obstacle sensor is still turning the LED red when an obstacle is in its path. You can now see how obstacle and line sensors can help a robot and its programs interact with the environment around it. Additional obstacle and line sensors can be added to further enhance this capability. Leave the circuit assembled for use in lesson B-14. Go ahead and move on to lesson B-14 where I'll show you how to use an ultrasonic range sensor.